Good morning, boys and girls, and welcome back. Mr. Mortara here again to help you learn how to add and subtract rational expressions that don't have a common denominator. Okay, these ones we're going to have to do a little bit more work on. We're going to have to find, again, if you remember, what's called a lowest common denominator, or the LCD. And that's the smallest number that both denominators will go into, right? The lowest common multiples, shall we say. Alright, so let's start here. Let's go back and let's review using some, just regular old fractions. If I had 5, 6 minus 1/3, right? In order to be able to subtract those, I need to be able to get a common denominator, right? So, one way to approach this would be, I'm sure we all know, hey, what I'd have to multiply the 1/3 by to make it the same denominator. But one way to approach this, in line with what we're going to want to do with our algebraic expressions, is I might want to factor the 6, and let's see what parts we have. So if I prime factor the 6 is really 2 times 3. So if I write 6 like that, I can see that what this fraction here has, it's got the 3, it's missing. And so that's kind of why, like back in the day, we said, hey, let me multiply by 2 to make those the same. 3 times 2 is 6. I can see that from my factorization. If I do it to the bottom of the fraction, I have to do it to the top. Why did that just disappear? That was weird. So I'm going to have to multiply by 2. All right. Now the bottom's the same. They're both 2 times 3 or 3 times 2. So we have 6 on the bottom. That's our common denominator. What am I doing here? 6 on the bottoms. My thing is switching on me here. Alright, so we have 6 on the bottoms of both fractions now. And on the top of this one, we didn't do anything, so that's still a 5. And then on the top of the other one now, 1 times 2 is 2. And so now, this is a problem just like yesterday. Okay, that's really the only part we're adding today, is getting that common denominator. Once the denominators are the same, I tell my kids, especially if it's a subtracting problem, distribute that negative. And so now I just got to do 5 plus negative 2, or 5 minus 2 is 3. The bottom stays the same, 6. And then now, when you're done, reduce. Okay, now I got to reduce. 3 over 6 reduces 2, divide the top and the bottom by 3, 1/2. And that'd be our answer. All right, let's try it one more time with regular fractions. And I said regular fractions, I guess little spicier fractions, all right? Here we have 5 over 3x minus 3 over 4. So these are not just quite regular numbers, but very close. We also have, a simple algebraic expression with us here. I'm going to tell you, you want to break up the bottoms into parts and think about it a little bit differently, right? This is the way I kind of break them up and how I think about it. On a denominator, when we're getting into this stuff here, you're going to have a number part or a coefficient part. Okay? So that would be like the 3 and the 4. I'm going to want to make those parts match like we just did in the part before. You're also going to have a variable part. I'm going to do the V, a variable part. And so that's like our x right there is the variable part. And I got to make my variable parts match. But that's like an x squared, an x to the third. If it's just an x or the variable by itself, no plus or minus stuff. If there's plus or minus stuff, then I don't have any of this here. That's what we're going to get to here in a second. But the other part would be, I call it a factor part. If you've got stuff in parentheses, an x plus 2, an x minus 1, an x plus 4, okay? So you need to make sure all 3 parts of the bottom match in order to get a common denominator. The coefficient, the variable, and the factor part. All right? So in this case, applying that knowledge now to this problem, I'm going to look just at my variable part, just the 3 and the 4, and I'm going to find that lowest common denominator. So, like we've done in the past, all right, you could say, hey, I'm going to have to multiply this equation by 4 to give me 12, and this one by 3, or not equation, this fraction, this denominator, and that would give me 12 on the bottom of both of those things, all right? So now my coefficients are the same on the bottom. If I did the bottoms by those numbers, I also have to do the same to the top, because I'm really multiplying by 1, and that's not changing anything. All right, so 4 times 5 is 20, and 3 times 3 is 9. So I've got the bottoms to match now. After I get the coefficients to match, then I have to make the variable part match. This one has an x. That's good. This one does not. So I'd have to also multiply by an x on the top and bottom so that both bottoms would have an x in it. Okay? And so 3 times 3x now is really 9x. Right? It's a little weird the first few times you do this, but that's how we're going to work to get a common denominator. Once they're the same, again, now it's no big deal, but I think the hardest part today is getting that common denominator. Plus a negative should be your negative, and so we get 20 minus 9x all over 12x. And like we talked yesterday, you really should, when you get to one fraction, don't do it beforehand. You don't want to kill beforehand. I get a lot of kids trying to do that, and they're going to kill off our common denominator. You cannot kill until you're onto one fraction. But once you get to one fraction, and if you want to kill, you have to factor. Can I pull anything out of the top? Nope. So in this case, I can't, but I should think about it. And if you can't pull anything out when you have one fraction, then you can't kill, and that's my answer. 20 minus 9x over 12x. Okay? No killing 20s and 12s. No killing 9s and 12s. Again, because you're adding, subtracting, you cannot kill. If you want to kill, you have to factor first. Can't stress how important that is. All right, so moving on to number 4. If I want to put these together, I do not have a common denominator, so I need to go get one. All right, so I kind of set up, and I do my blank plus blank, my fraction plus fraction, and I look. And again, I start with the coefficient or the number part. If I'm looking at coefficients, I have a 4 and a 1. So my common denominator would be a 4. I'm going to look at my variable part. In this case, I have an m and an m squared. You can never go down with the numbers or the variables. You only can go up. So I have to grab the biggest thing, and so m squared is the biggest piece. So 4m squared would be our common denominator. So this fraction here, I'd have to multiply by 4. And this fraction here, I'd have to multiply by an m to give me m squared. So I'd have 4m squared and 4m squared. Okay. On top of this, we get 4m. On top of this, we're going to get negative 24. And now I can, again, because the denominators are the same, I can put it all over 4m squared and 4m minus 24. All right. And like we talked about, once you get here, now try to factor. Okay. See if you can kill stuff off. In this case, I can do some factoring, and I can pull out a 4 from the top. And so because I can pull out a 4, and because that is now multiplying, I can do some killing off. I can kill the 4 and kill the 4. So your final answer here would be m minus 6 over m squared. Do not go kill m's here, right? Because that's subtracting. Oftentimes, I will leave that in parentheses to remind myself that I would need another m minus 6 to kill it off. And that's our answer. Okay, for this next one, x over x plus 1 minus 1 over x. We can multiply the top and the bottom by the same number, but you cannot just go and add 1 to the top and the bottom. Okay, that's not the same. If I have 1/2 and I add 1, 2/3 is not the same as 1/2. That is not legal to do. All right? So again, when you see something like this, it goes back to our parts. We said there's a number part, a variable part, and there's a factor part, right? Or factor parts. So in this case here, this x plus 1, because there's a plus sign, is a factor part. In my common denominator, I'm going to need an x on both of these. That's the variable part. And I'm going to need an x plus 1, and that is the factor part. You might remember an easy way to kind of do this too sometimes is you guys think, hey, I just got to multiply the denominators together, and oftentimes that will work. Not always. That'll always give us a common denominator, but not the lowest common denominator. Okay, so be careful. In this case, now to get an x times x plus 1, I'd have to multiply by x. And I'd have to multiply this one by x plus 1. So I get x squared over x times x plus 1 times 1 times x plus 1 is x plus 1. Now again, here's where I would say what I'm going to do is I'm going to distribute my negative to everything there. I think that is the safest bet when you're subtracting. And then so we get x squared minus x minus 1 over x times x plus 1. Try to factor. In this case, you cannot, but think about it. That's an easy trinomial. Therefore, because you cannot factor, that is my answer. And we're there. Okay, so for this next one, now we have m plus 2 and m minus 2 on the bottom. Not the same, and not the same as yesterday either, right? Yesterday we had like a 2 minus m and an m minus 2. These are slightly different. They're different signs in the middle, so we can't make them the same just by using our little switcheroo trick. Okay, it's not going to work here. Whenever I see stuff like this, again, I think it's a good idea. Put that in parentheses. And so like in this case, there is no coefficient part, or you could say it's 1, like on the last one. And there is no variable part because they're all inside of these factors. So in this case here, we just have two factors, and they've got to be the same on both, right? I need an m plus 2 and an m minus 2, and I'm going to need an m plus 2 and an m minus 2. I just need the factor parts to be the same, all right? So for the first one on the left, you're going to multiply by m minus 2, and on the one on the right, I'm going to multiply by m plus 2. On the bottoms, you do not have to multiply out. Notice I'm leaving it in factored form. On the tops, though, when I multiply here, I want to multiply out. You need to multiply out because we're going to combine the like terms on top. So I get m squared minus 2m. Over here, I get 4m plus 8. Okay? On the bottoms, leave it in factored form. On the tops, make sure you multiply out. And again, no killing. What you guys try to do is try to kill like m minus 2s and m plus 2s off. But no killing until you have one fraction. Okay, we're trying to put stuff together here. Because we're subtracting again, change the sign and distribute. And so I get m squared minus 6m minus 8 over my m plus 2, m minus 2. All right, and again, I'm going to try to factor. This one's looking promising. Hey, things that multiply together to give me negative 8, add together to give me negative 6. But 4 and 2 can't give me a negative, so I can't factor it. That's my answer, but that's what I'm thinking I got to try to do anyway. Most of the time, you're not going to be able to. Every once in a while, you will be able to. All right, starting to get as tricky as we can be here. Sometimes you're going to see that, I've got these things, but again, going back to our first example, I don't know what's right here. This is something that I can factor, and so you need to factor it. X squared minus 16 will factor to x plus 4, x minus 4. Now I can see the factor pieces that I need for my common denominator. I can see that I'm going to need an x plus 4, x minus 4 on both bottoms. This already has it, so I don't have to multiply by anything. I'm going to get 24. On the top over here, I'm going to have to double distribute now, and I have to multiply by x minus 4. So when I double distribute over here, I get x squared minus 3x minus 4, and so now I have that answer there, and I can distribute my negative and put the tops together. Once it's in one fraction, now's when you're going to try to factor to kill things off. And in this case, it works. We get x minus 7, x plus 4. And in this case, hey, I got something that I can kill off. I can kill off the x plus 4s. And so x minus 7 over x minus 4 is our final answer. Okay, so if we're given a problem, number 7, first step, factor the bottoms if they can be factored. You want to be able to see the pieces that make up each algebraic term. Okay, x plus 3, x plus 3, x plus 3, x minus 3. Then you can find your common denominator. Because the first fraction has x plus 3, x plus 3, I need two x plus 3s, and then I'm also going to need an x minus 3 because the second fraction has an x minus 3. All right, this one I'm going to have to multiply by x minus 3 to make them the same. That already had one of the x plus 3, so I only have to multiply by one more x plus 3 to make it match. Make sure you multiply out and distribute on the tops of your fractions. And then you can go ahead and combine the like terms on the tops, and the bottom's going to stay the same. Combine your like terms, and again, you're going to try to factor, but a lot of times it won't work out like I did last time, and that's going to be our answer. All right, one more. Here's the moral on the story in the last one. Pay attention to what you're doing. We are no longer adding, subtracting, right? So don't apply adding, subtracting rules to a multiplying problem, or if you're, don't apply multiplying rules to an adding, subtracting problem. Make sure you follow the right operation. In this case, this is a review problem, and we just need to factor and kill. To remind myself that I can't kill off when I'm adding and subtracting, I put the x minus 5 in parentheses. This is an easy trinomial with factor to x minus 5, x minus 1. I can GCF out a 2, and then that's one term, so I'm not going to factor that. Now I can kill off all my like stuff, one top, one bottom. So the x minus 5s die, the x minus 1 dies. I can reduce the 2 and the 4. If you kill everything on top, you're left with a 1, and on the bottom I'm left with 2x squared, and there is our reduced answer. All right, boys.